So we saw in the last video that data is really important for engineers because it helps us to make decisions about things. And in this video, we're going to look at how we can best record that data so that we can use it to make decisions. Because if you record data without including all of the information you need, then it becomes completely useless and you end up having to go back and redo whatever you've done to collect that data, whether it's an experiment or a literature review or talking to somebody or doing a design. Now, the traditional way that engineers used to use to record data is a logbook, and most engineers still have logbooks now, whether it's an old paper version like this one or a more modern version on a tablet or on a computer digitized. So this is an example of a ship's logbook, which I guess is where the name came from. The ships used to log, as you've seen earlier in the week, the ships used to log their location. They'd log the day of the week, they'd log their location, their bearing, their speed, and lots of information that would help them to calculate their course and figure out where they've been. And as we've seen earlier in the week, it was really important that they did this regularly so that they could land in the right place, so that they didn't sail past New Zealand where they were aiming to land. This is an example of one of my old logbooks. Now, when I was doing my PhD, I got through probably a dozen logbooks or so in the course of the few years I was studying for, and I filled them up with all sorts of information. I filled them up with information from my literature review, so where I was looking in books and at journal papers to find out what other people had done in the area that I was looking at. I filled them up with ideas, I filled them up with designs for experimental equipment, I filled them up with information other people told me. So while I was trying to figure out how to do the electrical bits of the experiment, I'd get advice from people who knew about the electrical stuff, and I'd write down stuff, I'd draw circuit diagrams so that I could go back to them and refer to them later on. I'd also use it to do calculations, and you can see here this is one of my more recent logbooks. So this is one of the, I think this was me testing out an exam question for one of the first year subjects that I teach, the thermodynamics subject. So I was working through it and checking that it was giving me sensible numbers. So you may already have the equivalent of a logbook. So you may have folders or notebooks that you use for each of your subjects where you've labeled them, you work through calculations, you label them with each topic that you're looking at, and maybe you've got a different section of the logbook for each topic. So you may find that you're already quite used to using logbooks. I have since moved on to a digitized version of a logbook now because I find it easier. Basically, I ran out of paper notebooks while we were in lockdown, and instead of ordering myself a new one, I thought I'd switch to my iPad and I'd start using that instead. So I've got the OneNote app on my iPad, and it allows me to have basically one book per project. So you can see I've got lots of different projects going on here, and the one that's highlighted, this is the Year 1 Thermo course that I'm planning some material for. Within each book, it's subdivided into topics. So I've got a topic for the content, I've got some for ideas, I've got one for the meetings, and so on. And then within each one of these subtopics, I've got a page for each bit that I think about. So here I've got it divided into the content for each week. And then I've got some other pages where I'm thinking about changing the content and writing down ideas and things like that. And I'm finding this quite useful because it's easy to flick through things and I don't have to carry around 10 logbooks with me at the same time. But as you progress through your engineering career, you'll find what works best for you. You may want to stick with a paper book. A lot of people do. It's very easy to do a paper book. You can scribble around in it. It doesn't have to be tidy or anything like that. You may prefer to switch to, or you may already have switched to, a digital version. And you may find that it evolves with time as well. Depending on what projects you're doing, you may find that having a paper book is easier to take with you if you're going into a lab somewhere where it's messy and dirty and you don't mind your paper lab book getting covered in oil, but you don't really want your computer to get covered in oil. So you may find that you have different logbooks for different projects, and you may find that as you progress through your career you need different things from your logbooks as well. But it's a good idea to get into a habit of writing stuff down. Write down everything, because you don't know what's going to be important to you when you come back to look at it in days or weeks or months' time. You'll find when you come to university that having a logbook and getting into the habit of using it is really important. You're going to be responsible for all of your own learning, so writing down everything that happens in your lectures is going to be really useful, and then you'll be able to refer back to it. You can highlight places where you've got questions, and then you can remind yourself when you go back to it which bits you need to clarify. So I'm going to show you an example of a page in a logbook that I may have done for a turbojet lab. So I start off the page with a title of what I'm doing. So this is a lab that we used to do in first year. We used to run a turbojet engine, a small one, not a full-size one, a very small one. We used to run a turbojet engine and we used to look at the performance of it. So on this page in my logbook, I may have the title. I should always have a title so I know what's going on in this page, and then I would have the date as well so that I know when I did it. I would then write the aim of whatever I'm going to do on that page. So the aim of this particular lab was investigating the performance of a turbojet, so I write that down. And then I may add any notes that are relevant to what I'm going to do. So here I've made a quick note about what the method was that we were using. So I said we're going to vary the throttle from 20% to 100% of its maximum value, and we're going to record all of the data that's shown on the equipment. I've also added a bit of a cross-reference here to the lab handout, which is on Blackboard, where I could look for the diagram and I could look for a bit more of a detailed methodology. Ideally, what I'd do is maybe print it off and cut it out and paste it into my paper logbook, or maybe I'd screenshot it and copy and paste it into a digital lab book so that I have all the information that I need in one place when I come back to it. Because you never know when Blackboard's going to be down, or when the lab handout's going to disappear, or you'll lose access to the course because you've graduated. So get all the information that you can in your logbook. Now in this particular lab I needed to set up a table because I was varying the throttle and I was going to record a bunch of values for a range of different throttle settings. So I set up my table like this. Now there are some key things to note about tables. I've got a title row here where in each column I say what I'm going to write in that column. So you can see the first column has got the throttle, and I include the units in each title row as well. So the throttle is a percentage of the maximum, so it's not a great unit, but the next one across you can see that's the speed that I'm going to record, and that's in revolutions per minute. So I've included the units at the top, and these are probably the units that the machine is going to output for me. Most of this lab, the values are output on digital displays next to the turbojet, so it's just a case of writing down the numbers that you see. But if you don't write down what the units are in this lab, you're not going to have a clue what the speed was, whether it was in revolutions per minute or radians per second or something else. And that makes it very difficult when you then sit down to do some calculations to calculate some of the performance parameters. It makes it very difficult to do those calculations if you don't know what the units were for the speed, because the difference between revolutions per minute and radians per second is quite large, so we don't want to be getting muddled up there. So you can see I've done that for all of the variables that I'm going to be recording. And then I might say, okay, well, I know I'm going to change the throttle from 20% up to 100% and say I'm going to do it in 20% increases. You can't see all the way to the bottom of the table here, but it would go all the way down to 100%. So I fill in the values that I know I'm going to be working with. So I'm going to set the throttle to 20%, and then I'm going to write down all of the outputs from the machine. But I can set up my table with the throttle values that I'm working for before I go into the lab, before I start taking measurements, so that I know what I'm doing. It's a case of it helps me plan. I then might start taking some data, so I set my throttle to 20% and I start filling in this row of data in the table. Now you notice that I'm using different numbers of significant figures for each column, and that's because I'm writing down everything that is shown to me on the displays. So I'm not going to round the speed down to 2 significant figures because that would remove quite a lot of the information that I'm being given. So for now I'm just going to leave it like that, write down all of the digits that I'm getting from the displays. I then might move on and change the throttle setting and fill in another value, and so on until I've filled in my table. And now, because this is my logbook and I'm going to want to come back to it at some point, I might make some notes about things that I noticed during the lab that I might need to look out for when I come back to look at this information again. So I might note down that the air flow rate and the fuel flow rate, although they're both flow rates, I've got them in different units here, and they're also not in SI units there. So I'm going to want to do something to them before I do calculations with them. And I might highlight that using a different colour pen just to make sure my attention is drawn to it when I come back to look. I might say that the pressure is not an absolute pressure, so it's relative to atmospheric, it's a gauge pressure instead of an absolute pressure. That's an important thing because that means that the absolute pressure here in the first row would be 1.17 instead of 0.17. And again, that's going to make quite a big difference to my calculations. And then another thing to look out for is the temperature. It's in degrees Celsius, and I'd probably want it to be in Kelvin for my calculations. So it's just highlighting these things as they occur to me during the lab while I'm there. Maybe the lab demonstrator mentions something that I want to note down as well. And it's just making sure that you fill in that logbook with all of the information that you have, so that when you come back to it to do some calculations on it, you've got all of the information you need to be able to use that data properly.